Have you ever been walked in on by your parents or boss when you're doing work? Wouldn't it be nice if you didn't have to worry about that? Well, I think I engineered a solution. I'll be documenting my whole process here, so if you just want to see the final product, skip to this timestamp. However, if you care about my process, then continue watching. To start, let's rewind a few weeks. To start this project off, I needed a way to reliably detect motion. I had this PIR motion sensor from a few years ago I got from an Arduino starter kit, but I didn't know if it would reliably detect motion or not. To test the motion sensor, I connected it to an Arduino Uno and ran the motion sensor code from the sample Adafruit Arduino sketch library. So I have it all set up here. I have my motion sensor connected to an Arduino Uno, which has an LED connected to pin 13. When I put my hand in front of the sensor, the LED goes off immediately. It stays on a while after my hand leaves the sensor, but this is fine since I just need a signal as soon as motion is detected. The sensor is also really sensitive, so I'm going to need to tape it down or put it in a really stable place, or else I'm going to be getting a ton of false alarms. My idea is to send the keyboard command Ctrl-W through the USB port whenever motion is detected. For those who don't know, Ctrl-W basically closes the browser tab that you're using. However, it turns out that the commands needed to send keystrokes through the USB port are only available for 32U4 and SAMD boards, such as the Leonardo, Esplora, Zero, and Duo. Since I only have an Uno, I'll need a new board to do this. I chose to not go with the Arduino board and actually go with a Raspberry Pi Zero for 3 reasons. 1, I actually just wanted a Raspberry Pi. 2, I like the fact that it had Bluetooth and Wi-Fi, which I thought may come in handy in the future. And 3, I like that you could control the GPIO pins with Python, which is a language I'm more comfortable with than Arduino code. I'll catch up with you when the Raspberry Pi arrives. Once the Raspberry Pi arrived, I sloppily soldered on the GPIO pins with the broken $5 soldering iron from Harbor Freight. For my first program, I used PiMyLifeUp's motion sensor code to test if the sensor worked reliably on a different interface. After I ensured it worked, I needed a way to communicate with my computer. After a bit of research, I found iStick2It USB. iStick2It USB allows the Raspberry Pi to act as a USB keyboard. Therefore, you can send keystrokes through the USB port. I implemented this into my code by sending the command Ctrl-W whenever motion is detected by the sensor. So here's the basic setup. I have a motion sensor connected to a Raspberry Pi, which is connected through USB to my desktop. It's also connected through SSH to my laptop, so I can control the program remotely. Usually I'd SSH into the Pi using my desktop, but since I'm going to be turning on the program at the end of the hall when testing, I need to do this remotely. Okay, so on my desktop I'm focused on a Chrome tab, so hopefully when motion is detected by the sensor, it'll send the command Ctrl-W and the tab will close. Now that I'm far enough away from the motion sensor that I won't accidentally trip it, I need to start the program. Once the initialization message is sent, then I know the system is armed, and hopefully, when I walk into my room, the tab closes just like I wanted it to. I did the test about 100 more times to test the device's reliability. The sensor sometimes triggers early because it's really sensitive, but it's fine since it never failed to trigger when I walk through the door. What I have now is pretty good, but it's limited to only closing either one tab or one window using the command Ctrl-Shift-W at a time. A much better implementation is using a throwaway browser. This allows you to close all the tabs you want as soon as motion is detected. This way you don't need to arrange all your tabs in one window, which can be done incorrectly and can lead to some tabs being left open after the program runs. This also allows the program to be run in the background, since if you're not doing anything you want to hide, then when the program runs, nothing except for the throwaway browser will be closed. To implement this into my code, I created a Python script on my desktop. I used thisTutorial.pytutorials to detect the hotkey Ctrl-Alt-W, which is an unused keyboard command in Windows. Whenever this hotkey is detected, I use a command from os.system to kill the firefox.exe process, which is the throwaway browser I'll be using in this case. I also use thisTutorial.pytutorials to send an email to my phone whenever motion is detected. So if I'm doing anything on my phone, then I'll also be alerted. To do this, I need a sending and a receiving email, and I need to enable Less Secure App Access on my sending email. The code is pretty simple. I basically use the PyTutorials hotkey code, and inside the execute method, I use os.system to task kill the firefox.exe task. I also used smtplib to send an email from my sending email to my receiving email. I only needed to slightly modify the motion sensor side code by changing this 1 to a 5. This sends the command Ctrl-Alt-W versus Ctrl-W. So if I start by running the desktop code and then run the sensor code, when I put my hand in front of the sensor, it closes the Firefox tab, and hopefully in a few seconds, it sends an email to my phone. You can stop here if you want, but the thing is, when the motion sensor is tripped, you can see a brief flash of the tab closing, which pretty much ruins the effect. A good solution to this is running the motion sensor outside the door, which isn't actually a bad idea, since the Raspberry Pi can be powered by just the USB connection to the desktop. However, this also kind of ruins the effect, since if you can see the motion sensor, then the person who tripped the motion sensor will already know that you're doing something you want to hide. An obvious solution to this is making a wireless connection between the Raspberry Pi and the motion sensor. The way I'm going to be doing this is by using RF signals to communicate between the two. I ordered a few nRF24L01 modules from Amazon, and they should be arriving soon. So I got my transmitters, and as a proof of concept, I'm using How to Mechatronics guide for the nRF24L01. I edited the code so that every second the transmitter sends a signal to blink the LED connected to the receiving end, and I also changed the PA level to max so I could increase the range of transmission. To show you guys that the receiving end isn't just blinking the LED every second, if I unplug the transmitting end, the LED will stop blinking, and if I plug it back in, it starts blinking again. So I did the tests, and the results don't look too promising. Range is actually pretty good, but whenever the signal is intersected by a wall or a human, the signal degrades dramatically. This is bad since if the modules aren't connected properly when motion is detected, the tabs won't close and you could get caught. This is further magnified by the fact that the motion sensor trips whenever somebody walks in front of the sensor, and the RF module drops connection whenever a human is standing in front of the module. This leads to a very unreliable system, and I would not trust it to close my tabs. This is what happens when I walk in front of the RF module. The light stops blinking, and it'll only start blinking again when I walk away from the sensor. So it looks like the idea to communicate between a Raspberry Pi and a motion sensor using an RF module like this isn't the best idea. I need to come up with a communication method that doesn't get interrupted when someone walks in front of the motion sensor. I don't know what that is yet, but I'll come back to you when I do. So I was looking for other ways to communicate between a motion sensor and a Raspberry Pi, and I found out that you can use network sockets to communicate between two Pis. Network sockets allow you to send data through Wi-Fi, and the benefit of using them is that no matter how many obstacles are in the way of the connection, the signal won't drop. Network sockets allow you to send data through Wi-Fi, and this is good because no matter how many obstacles are in the way of the direct path between the two nodes, the signal won't drop. My initial idea was to buy another Raspberry Pi and use my pre-existing hotkey code to detect a hotkey, until I realized that I could just do it directly and communicate between a Raspberry Pi and my computer. This way I don't need to buy another Raspberry Pi or listen to a hotkey on my computer, which increases reliability since there's less hurdles to go across, from the motion being detected to the tab closing. So basically, I use Alexander Baron Harper's code from his Practical Socket communication tutorial with a few tweaks. On my client side, I have a while true loop that constantly checks the status of a motion sensor. When motion is detected, which is signified by the current state variable being equal to 1, the message detected is sent to the host IP address at the port that I specified. For the server code, I basically just added an else if statement that checks if the command that the client sent is equal to the string detected. And if so, it runs the close file function, which uses os.system to task kill the firefox.exe process. I connected the Raspberry Pi to a 10,000 mAh portable charger so I can run the whole system wirelessly. If I start by running the server, and then run the client, when I put my hand in front of the motion sensor, the Firefox tab closes almost immediately, and the whole thing is done completely wirelessly. At this point, it works pretty much perfectly. You can SSH into the Pi and put it pretty much anywhere and it should work. But I feel like the user interface of the server limits the functionality a lot, so I'm going to be creating a GUI so the user can change settings without having to mess around with any code. Here's my design for the GUI. I have a server kill button that kills a server and a hide button that hides the GUI. I can make this reappear by entering the command Ctrl-Alt-W. The next row allows me to enter in a program I want to close when the motion is detected, and I can set it by pressing this program name button. The next 3 rows allow me to toggle whether I want to send an email, close a program, or close a tab when motion's detected. To toggle the options, you click the labels and its status will be indicated to the right. These next 2 rows allow you to set a sending email and its password, along with a receiving email. When you want to change these variables, just click this set credentials label and it should be set inside the code. Finally, this last row at the bottom is a label that allows the user to see what's going on inside the program. Errors and status should be displayed here. In order to get the GUI to run while the code checked for the client, I needed to set the GUI inside a different thread so they could run simultaneously. I had to do the same thing for the hotkey. I converted the .py file to an exe. This way I can run the program without a console. I know I can do this by just using a .pyw file, but for some reason when I did this, I couldn't send emails. This also allows me to make a logo, which I would say makes it look better, but also makes it look more professional and therefore would draw less attention to it than the stock py file. To do this, I linked a good tutorial in the description. I also have the icon file for the logo I made in my GitHub. So I have my server up here and I'm going to set all the options on. Then I'm going to set my credentials and set the program I want to close to Firefox. The windows I have in the back here are a Firefox window and an incognito Chrome tab. The close tab function just presses the keys Ctrl-W, so I'll need to keep focused on this Chrome tab. I also have the receiving emails inbox right here, so when motion's detected, I should get a new email here. To start the program, I just need to run this Python file on my Pi and focus on the incognito Chrome tab. Then when I put my hand in front of the motion sensor, both of the tabs close, and in a few seconds, I get an email on my inbox. So that's it. As long as you set up the program correctly, you'll never get walked in on again. There are still some improvements I'd make to the design. I'd like to have a more compact enclosure so that the unit can be more compact so you can hide it more places, and also it will be less noticeable because it's a uniform color. Another improvement is to make a separate GUI or app that allows you to turn on the motion sensor. This way you wouldn't have to SSH into the BI to start the code, which would make the UI more user-friendly and also more accessible to people who aren't as tech-savvy. Another software improvement I can make is using JavaScript or Python to close a certain website. This way you can use your preferred browser while running the tab in the background. One thing to note is that I went into this project with no knowledge of how to use a Raspberry Pi and limited knowledge on how to use Python. I did almost everything by Googling my problem and finding the solution. Almost all the code in this project I didn't write myself. You may think this is cheating, but it's actually a big part of what programming is. Finding something that's already out there and modifying it for your own needs. You don't need to reinvent the wheel. Anyone can learn to code. The hard part is getting started. All the code for the server and client are in the GitHub I linked in the description. If you make this, I'd love to know, and if you have any suggestions, feel free to contact me. If you like this, like, comment, and subscribe, and if you dislike this, dislike it. See you next time.